Hello and welcome back to A Gal's Guide to the Ocean. It's your favorite host, Catherine, and JD. And today we are coming at you live with SLO1, which is covering ocean sediments.
Yeah.
Catherine, take it away.
Okay, so to get into the topic of sediments, we obviously need to know what it means. So sediments are the tiny particles of rocks and other materials that sink to the ocean, which will eventually settle and accumulate on the bottom. The amount of it accumulating, it depends on the region of the seafloor, but generally the average is 1 kilometer thick, and it goes up to 15 kilometers of thickness. And high accumulation is present in certain areas, such as near the mouths of rivers, where there is high sediment discharge, and passive margins near the continents. The area where there is not much sediment is along the plate boundaries, because this is where new oceanic crust is formed. So since it's new, it can't accumulate.
Ooh, that was really interesting, Catherine. I did not know that.
Yes. And that's not the only location. The other location is in the Central Oceans, because they're too far away from the sediment sources, so it's not possible for any sediment to accumulate. As time goes on, the sediment turns into rock, which is called lithified. I think that's how you say it. And now I will get into the classifications of sediment. And one of them is based on texture. No, the three. I'm going to list the three. So the three are texture, composition, and the origin. So I'll begin with texture, and it's examined through several variables such as grain size. They're classified by particle size, ranging from finest clays to the largest boulders. Grain size represents the condition under which the sediment was deposited. When strong waves or currents occur, these larger particles will be the ones to be deposited. But when it's low energy conditions, the small particles settle out and form finer sediments, since the energy isn't that high. And now for another way to categorize sediments is by sorting. This basically means how uniform the particles are in terms of size. So for example, when the particles in the beach are all similar size, this means it's well sorted. And when they're not all similar, this means that it's not well sorted. So it's vice versa.
Okay, just like Catherine talked about classifications, they're based on the source of origin, which is the four main categories. And those are, excuse me for pronouncing them wrong, lithogenous, and those are when sediments are kind of derived from pre-existing rocks, aka terragenous sediments. And the second one is biogenous, and those are sediments that are composed of the remains of marine organisms. And then the third is hydrogenous, and those are when sediments are formed when materials are dissolved in the water and then precipitate out and make solid particles. And then the last category is cosmogenous or cosmogonous, I believe. And those are when sediments derived from extraterrestrial sources. So that would be, for example, like asteroids and meteors. Very interesting.
The space?
Yes, the space.
Oh. Okay, so there's different organisms that are the primary resources for biogenous sediments, which JD just talked about. So those resources are one-celled algae and protozoans, and these live in the surface waters of the oceans. And they're important because of the tests that come out from them. So when these tests compromise greater than the 30% of the particles in the sediment is called an ooze, and oozes are more abundant or most abundant beneath open ocean areas where nutrients are available to enhance productivity. In these areas, oozes accumulate at an average rate of 1 centimeter per 1,000 years. Um, but oozes don't really happen on the continental margins where genus sediments dominate, which JD also talked about. As I was talking about the tests, these tests are of calcium carbonate or silica. The silica tests are from diatoms, which are algae, and the radiolarians, I think that's how I say it, which are also protozoans.
Okay, so another like essential question is understanding the factors that determine the distribution of sediment types in the ocean. And so that can mean a lot of things. For biogenous sediments, the distribution is kind of dependent on the rates of production, as well as dissolution and dilution by other sediments. And so these sediments are more common in pelagic environments. And since they're pelagic environments, they have little lithogenous input. However, in general terms, they're dependent on factors like distance from, like the distance from the land, right? And also the climate. Like temperature is very important, as we've discussed in earlier SLLs and chapters. Also water depth and water temperature, which I literally just said a second ago, as well as primary productivity. So yeah. Okay, and basically one of our last ones to close off is understanding how biogenous sediments can be used to reconstruct past climate change. This one's really interesting because I didn't really think about how it could like repair and reconstruct the climate change. So basically, they allow us to reconstruct past climate change history from oxygen isotope ratios. Okay, so now the explanation is kind of like oxygen atoms come in three forms, right? And so, or isotopes in the ocean water. And for those three, it's O16, O17, and O18. And so the numbers is basically just the atomic mass of isotopes. And don't get me wrong, it's been a while since I took chemistry, so I'm a bit rusty in this section. But O16 is the most common, and then O18 is 2, but O17 is rare. And so O16 is lighter than O18, and that's valuable because it kind of evaporates easier, and so water vapor with a higher proportion of O16 is like more commonly found. And so anyways, when we have a cooler climate, the water vapor condenses into rain and snow, which is kind of self-explanatory because we learned this in middle school too, with the whole like the water cycle. And so this eventually makes glacier ice with a high proportion of O16, and so that remaining water has a higher proportion of O18. So whatever's left becomes O18, right? And so basically the ratio, which is O16 to O18, in shells is lower in cold periods, but during the warm periods, the glaciers that formed earlier in the cold ones melt, and so they release all that O16. So then it increases the ratio. That would be I'm not sure if it's from O16 to O18, but I do think it changes to O18 to O16. And so after, of course, calculating that ratio, you can kind of guesstimate that the climate conditions, when the shell starts when the shell starts to form, were formed. So it's all very dependent on calculations, and that's why I said, like, don't get me wrong with chemistry. It's been a while since I've taken it, but it's very relevant to the situation. So with that, we are now concluding SLL 1 in ocean sediments.
Yeah, okay. We'll see you.
on the next SLO, which is SLO 3 and our final SLO. So, goodbye.
Bye.
Oh, subscribe.